Yeah, we got. I got 6 pounds of wine.
Let me check outside.
And that's all right with me. That's all right with me.
All right, guys, let's get started. Let me grab one. Everybody got one of these? If you don't mind, turn your phones down or on silent. We are recording this, so keep the commentary PG, please. All right.
I'm in trouble.
Yeah, but so if y'all look into this, we've got a couple of functions that we want to, or a couple things we want to accomplish with this class here. One, ECONET zoning. Two, a little bit of understanding airflow, which is important to the ECONET zoning. So all this information you found here, I printed off of actual my Ruud site. So you can go to your app, or you can get on my Ruud and you can get this information, but I know you guys won't, so I did it for you. All right. Also, I've got my card here, and Dave Reaka is available all the time too. So with that, this is Dave Reaka. He's my counterpart in the north. A lot of you guys have talked with him, dealt with him. All right. So he's going to be the lead on this, but if we need to, if you have any questions, both of us can answer. We'll both hop in here, and hopefully we'll learn something today, okay? Again, it is being recorded, so if anybody's uncomfortable with that, let me know, but if not, let's try to keep it civil, and don't be afraid to ask questions. We'll go for about 60 minutes, take a piss break, and then we'll go again, have food at the end, okay? So, hope you guys learn a lot, and we'll just go from there.
Morning.
Okay, it's all yours.
Weather's great, at least it ain't snowing.
That's right.
I'm Dave Reaka. Everybody in here does zoning. Is that why you're here? How many people have done an ECONET zone? Anybody? Okay. How many people understand how these, and I'm going to start this boring, but what we need to understand to begin with is that we know how these motors work. Because where I'm starting with this is CFM and static pressure. The old days of zoning with a straight zone system, where we got this right here, we put a bypass right in a return drop right off of plenum, and a barometric damper are over. I mean, you still can do that. This was never really a great way of doing it. We got away with it because most of the time we use PSC motors, right? Now we're into these constant torques, and we're into ECMs. Do you know how these motors work? Because this is important when you're looking at zone a system, whether you should walk away from zoning it or whether it's zonable. Because not everything's zonable, okay? Anybody know how these motors work? Because I do a whole motor class, but I can give you a brief summary of how these motors work today. And this will even go past zoning. Because most of our problems in the field are undersized returns and oversized equipment, right? We walk in, we sell a job, we don't do a load calc, we oversize the furnace, and we're screwed. I don't care if it's zoned or not zoned, because of how these motors actually work. And this is the problems that we're beating our head against the wall every day, just about, because now these motors cut back. Back in the day, these ECMs burnt that little black disc up that was a limiter. That was because they was running too high static pressure. None of us ever really realized that. We just kept replacing modules, right, because they were warranty. About every 2 or 3 years. Well, now these motors are designed, they're communicating, they're going to start folding back and they're going to start throwing errors, especially when communicating, okay? So the basis of this is to understand our CFMs and our static pressure. And I've got a couple of short videos I can show you here on how the motors actually work, or we can actually do one on here live. But these motors measure static pressure based off the torque on these shafts. The torque on the shafts is communicating to the module, which is breaking it back down into CFM and static pressure on these thermostats. That's how they're getting CFM numbers, based off of the torque through the communication process, okay? There's a key on here, and it's the RPMs of the motor. So on all of our ECONETs, when you go to your your air handler or furnace, you can see CFM, you can see static pressure, and you can see RPMs. If you don't walk out of here understanding anything else, right now, the key RPM number is 1250. I don't even care, because if you're running over 1250 on these motors, I'll guarantee you you're running over an inch of static. And when it sees 1250 RPMs and goes up to 1275, 1300 RPMs on that motor, it starts cutting back to protect the motor, to keep the motor from overheating, and then it starts sending error codes through the communication process, and it has to start over. Okay? So,
can I add to that real quick? A lot of people don't understand that RPM that we're talking about. It doesn't necessarily mean speed. Okay? It's not. We can't think like PSC. The faster we're going, the more air we're moving. The constant torque in your variables, as we understand, we are trying to keep a certain CFM. So that RPM change is to keep, let's say we're trying to keep 950 CFMs, all right? That RPM change is going to change depending on how much static it's faced with to keep that CFM. So it's not a PSC motor, the faster speed, the more air we move. A constant torque is trying to achieve a certain CFM by the speed that it, or the RPM that it runs, depending on the static that it's facing. You guys got that? Good on that?
basically, if I'm looking for 1,000 CFM, as that motor ramps up, the CFM's not gonna change. If it says I want 1,000 CFM, that motor's looking for that torque on that shaft that says I'm moving 1,000 CFM, and it's gonna keep increasing the motor speed. So when these came out in '97, the big deal was, or '96, whenever these come out, was, well, these motors will overcome crappy ductwork, which was nothing but BS. It doesn't overcome anything. It just tries to keep achieving that CFM value across that coil or across that heat exchanger. Now, the second question I have for everybody is, does anybody know how many CFM for 10,000 BTUs of heat you need to keep a 90% furnace operational without tripping a limit? Nobody knows this. And this is where we're really running into problems with 90% furnaces and zoning. You need 150 to 160 CFM for 10,000 BTUs of heat. So guess what? If I put an 85,000, 96% furnace in, do the math. Okay, do 160 times 8. I need almost 1,300 CFM to keep that furnace from tripping on limit. Because you know what the limits are set at in these furnaces today? For all the old school guys that used to 200 and 180, some of these limits are 120, 130. They won't tolerate any more temperature rise than that, and you're tripping limits. You do that 3 times in a cycle, we got issues, okay? In some cases, some of our matchups have an 85,000 furnace on a 3-ton air conditioner or 3.5-ton air conditioner to get your AHRI numbers. You need more airflow for that 85,000 furnace than you need for that 3-ton air conditioner, gentlemen. And we don't realize that, and we're in trouble. The only advantage I have with the 96 Vs and now the 96 2Vs is they're 2-stage. So I can keep them maybe locked down. I can lock them down to just stay in single stage. Because we're oversizing furnaces too, let's face it. We are all oversizing furnaces. The days of walking in and looking at a furnace and going, well, it worked for 20 years, I'll just put that same size in here, is over. That's where we're getting into trouble. Because we're not doing loads, we're just doing a simple, oh, that worked for 20 years, and guess what? It don't work anymore. This is beyond zoning, but you gotta understand this, because when you're going to look at a zone system, I'm concerned more about CFM, and the smallest zone will handle what size AC and furnace in the smallest zone, even if I have to add a bypass, okay? Bypasses have always been supposed to be installed down the return line to mix with the air. Probably 70% of the zone systems are tied in with that, right here and right off the plenum, because guess where you're at? You're in a space where they got a full basement, and you got about 20 square feet to work with, right, for ductwork, so you can't do it. You have to do this. That's not the great, that's not at all good for communicating zoning. Because now I've got temperature supply sensor and return sensors in this ECONET zoning that's monitoring the temperature rises to you, okay? So having said all that, we'll get into the zoning. Sizing the equipment properly is the first key. If I'm zoning a job, it's at minimum a 96, it's a two-stage furnace at minimum. Really and truly, you're better off with variable. You're better off with a modulating furnace because, and the same with your outdoor units. Okay? And we'll get into the communicating and non-communicating, but if I'm using a non-communicating outdoor and I'm using a communicating stat and a communicating zone, I have to know what my smallest zone will handle CFM-wise. Two-stage outdoor units run at about 69, I think some of them maybe now 65% of full capacity on single stage. I only have two, well, my heat pumps are all two-stage, 14 SEER. Then you get 15, 16, and 18 SEER, which is variable, okay? I have to know what my smallest zone will handle. So I don't have a calculator. You can calculate if you get a 5-ton outdoor unit non-communicating, what's 60, let's just go 69% to be safe. What's 69% of 60,000?
It'd be like 1,400 CFM.
You're somewhere in there. So your smallest zone is gonna need to be able to handle that CFM for a 5-ton, okay? And when we calculate CFM of this duct systems, I don't care if my trunk size is 12 by 24 going in one direction. How many 6-inch runs do I have coming off of that? If I got 7 6-inch runs coming off of 12 by 24, it's the smallest part of the zone, right? I can't shove 1,400 CFM through 6-inch runs. And this is the other place we're running into problems with zoning. We're not thinking about that out of the box because we think we put a bypass in and we've solved all our issues, right? I can dump that air. Now I got options, which we'll go through. I can make a dump zone somewhere. I can maybe do leakage or over conditioning of the first zone and have leakage and create leakage. But that's not ideal because then your whole zoning's defeated, right? If I can't keep the temperatures where I want them in each zone. Okay? So that's where we got to start thinking out of the box. We have to understand CFM. We have to know how many of you guys use duct calculators when you size ductwork?
Calculator.
What do you size returns at? 0.8's okay. I just had a 3-day an 8-hour airflow class from NCI in over in St. Louis. You know what they want? National trainers. They want you to do 0.6, 0.5 if possible for return. I got guys sizing returns at 0.1.
Yikes.
Okay, that's wrong, way wrong. That's what a lot of the old school guys were taught. So if you don't know how to use a duct calculator and you want to know if you want to get a rough, and I don't like rule of thumbs, but if you figure 75 or 80 square inches per ton of cooling on return air, and your size of your return air, you measure all your returns, and you use that formula, it'll keep you out of trouble on return air, okay? I'd suggest you use a duct calculator, and that's a whole airflow class we can teach a duct calculator. But we have to pay attention to returns. I give you an example, and it's a pro partner, by the way. I was on a job in St. Louis yesterday. They had 6 by 11 and a 7 by 13 floor returns for a 4-ton system. So that's why I'm preaching. Sometimes it doesn't sink in. That's why I'm preaching. We've got to know how much return we have, because that's where we get into our biggest problem. Okay? Because of the way this sets up. Equipment and components. If you said you got all that in here?
Everything
in this envelope, because if you go, how many guys ever go to PTS, the portal you got? Nobody? Do you even know it exists?
No.
No.
You got to get a login. Wayne, you got a login?
Nope.
For what?
For Ruud's PTS portal. You have to have, because you got
He's got one for
password, you
my
got to have a
Ruud.
login.
He's got one.
Does it
Okay.
have it on the, is it on the My Ruud?
Yeah.
Yeah.
My
Then
Ruud.
okay.
Then you go, and I'll just show you here real quick. We dumped it. If you're laying out a zone system and you're not sure what you're laying out, or what you need for that system, if I go to my Ruud and do my login, mine's gonna look a little different, but you all should have this PTS,
You're still in
product technical.
You're still in presenter though. You need to exit,
Uh,
click layout presenter.
Alright, where am I at here?
There you go.
You all should have this, PTS, product technical support. Okay, if you click on that, it's gonna take us here. Maybe, come on.
With the rain, it's internet slow.
And you all should have logins to this. This is a valuable spot to go for information. And you can get there through your contractor app too.
That's what we're doing.
You can go through your contractor app, go down to thermostats in your contractor. If you're on PTS, we're gonna go, I ain't got it on my screen here. Go to thermostats,
Yep.
hit thermostats, and then when you hit thermostats, where's thermostats?
Very, very hot.
When you hit thermostats, you're gonna go to specs.
Specs. You have to select a thermostat. What thermostat do you want us to select?
ECONET,
The ECONET.
800, right?
No, it's just smarter on the control center.
I don't have it on this screen.
Go back.
That's the 600. Starting over again.
Yeah. So if you go into the ECONET stat, you
You
got
go to specs.
spec sheet.
Yep.
Scroll back up.
So you have two options for spec sheet.
The 1127, the 800 series, or the 102?
800. Where's it at, Chris? I don't have it on my screen here. Is 800 up there? Should be. I just looked it up on my contractor app.
I'm not seeing it.
No, it says it's not, nope, they're not.
It ain't up there for some reason.
What's on my contractor app?
We can do that.
Also.
When you go to the spec sheets, what I'm trying to say here in your app,
It's
you all
right
have
there,
your contractor
ECONET
app.
smart thermostat.
Yeah, that's what we went to, the ECONET smart set. Yeah, click on that. and
That
you'll
one's
get there.
okay. Why not? I can't see.
Go down,
down.
one more.
There we go.
I don't have it on my computer right now. Not the most computer savvy. I wanna go to specs.
Yep.
Latest specs. I'm gonna pull up sheets, and this will tell you all the equipment that's capable to be zoned, communicating zone, and all the parts and pieces you need for the communicating zone system. As you scroll down,
You went all the way to the bottom.
Yeah, it just shows
That's all I have,
specs
yeah.
for the thermostat, that's all it shows.
Mhm.
then that ain't the one. I thought it had 800 on there.
Now, there is another,
I thought I seen
selection on
800.
there. If you select ECONET Control Center, and then you select the spec sheet off of it,
Guys, when y'all get signed in here, then we'll have your email. I'll email you all out a page that I have put together that's all the combinations, so we can.
yeah, there's a control center one, and then there's also one that says ECONET Zone Panel, and it has a spec sheet as well. And both of those have, and basically links to this, what you just handed out.
Well, the ECONET there, I thought I saw 800 on there earlier when I looked. Thermostats. What is internet stuff? Spec sheets. One of them I scrolled down gave me everything
Yeah, and
that's
you-
the old one.
If you go back, just hit the back arrow, twice, so you get back to that, selection page, there is a, it's a zone panel.
Oh, it's one with the.
Yeah, it's basically the same.
It should give you the equipment that's available to zone.
Yeah, see right there.
Oh, yeah.
See it? But if you looked at 14, you see it
It doesn't
it's
stand anymore.
not there.
Because the 700 no longer exists. We want the 800.
So, yeah, do the same thing, remember that?
And as you go through your presentation, Dave, there's a slide on there that shows all the,
And then back to the top. Scroll down. Now there is a ECONET zone control on there.
Yeah.
Control
That's not
center.
giving me,
And it has a short list of what you can use for it, so click that.
this one?
Or no, it's the zoning one, where's the zoning one?
It's one right there, it's all there.
Zoning,
Yeah,
yeah.
that's a 700. The panel's still a 700, the new stats are 800.
And then the spec sheet. And it'd be the first one. And then about halfway down that first page, there's a list.
Should give us a list of all of the equipment capable of being zoned.
It does. Yeah. No, you went past it. It's right there. See, it says ECONET, communicating, outdoor, multi-stage AC or heat pump.
Oh, yeah, there's a second bulletin, right there.
Right there, there. That's the only thing that can be zoned today.
Okay.
With the communicating. Up, down, lower, data, so breakdown. Yeah, and here you go. Minimum airflow requirements for zoning.
which is all in those
For
pages.
your modulating, for your 97, 98 MVs, your two-stage, by size, that's the chart you need to see. That's the eye candy right there. So when you're looking at these zone jobs, if you come to this page, you need this chart in front of you when you're laying out a zone. 2 zones, 3 zones, whatever you're laying out. Okay? Non-communicating.
Just a side question.
Yeah.
Are there any talks of the 80% furnaces going away still?
Yes.
Do you know anything about that?
2008.
What's that?
2008, they're gone.
2008 or
I
20?
graduated high school.
28.
I was gonna say, you were dead set on
I
that.
was like, damn, I thought,
28.
oh, last meeting.
I don't even know it's 2024 yet, it's just going too fast.
2028.
2028 is the last we heard, the 80% are done.
God, that's scary.
Okay?
And they're not thinking about extending that or anything, it's gonna be toast.
Who knows, this stuff changes every day.
Yeah.
We've already changed, and that's a whole refrigerant class, there's still gonna be 410A equipment available after 2025, the way it looks.
Awesome.
But that's that's a whole nother day. But anyway, yeah, 2028 was the last we heard that they did finally decide they're getting rid of the 80s.
It's gonna be
Now, I've heard a couple of different things, it was new construction, no 80s, and I've heard no 80s, period, so. That's 3 or 4 years out, but as we know, that ain't that far out. But anyway, this might help you with your non-communicating 2-stage, your minimum airflows. Outdoor unit size, minimum airflows. So when you're non-communicating outdoor and you're communicating indoor, this is the minimum airflows you need per size, right? Again, the key here is the CFMs to the zones and what size equipment we're working with, and understanding on the 2-stage where you're at, if it's non-communicating. Does that make sense? I tell everybody, your best bet if you're gonna zone, and you really are limited for bypass space and all that stuff, it ain't cheap, but your best bet's your 18 SEER and your mod furnace, because I've got ranges from 45 to 100% to work with. Because when I lock in a CFM value in a zone, it's locking in how fast my outdoor unit's gonna run on the inverter speeds, where my furnace is gonna go. on its heating capacity, because my mod modulates from 45% to 100%. Where my 96 2V and my 96V today is 100% or 69%. So I have way more room to zone with a fully modulating system than I do with two-stage equipment. But if you got plenty of ductwork to each zone, you're fine with two-stage equipment. Communication process with the non-communicating outdoor is the CFMs it needs for the first stage of cooling or heating outside in the smallest zone. Does that make sense? Okay. Let me get out of this and get back to my PowerPoint. Leave it at that. And get back to my screen so I can see.
They don't want you using bypass. They want the dampers to do bypassing.
Give me my screen back here.
Confirming that, but man,
Okay, first of all, we want compatible equipment. Go away. You're going to use the 800 series ECONET. You're going to need the ECONET zoning panel. You're going to need the ECONET dampers and supply and return sensors. Ruud is using EWC. They're partnered with EWC. But keep in mind that that EWC control board we have right here is a communicating board. It is not a regular zoning panel. Because when I communicate, if you guys all put in some communicating equipment, it's R, C, E1, and E2, right? Everywhere. Unless I have a non-communicating outdoor. So I have to have RC and E1 and E2 bridge coming into this control panel. Okay? Does it make sense? Again, here's the equipment. I just showed you, struggled through it, but where to find the equipment you can communicate with and zone with ECONET zoning. All the other stuff you can zone traditionally if you want to. But the communicating equipment, you want to zone with the ECONET zoning because you have a lot more liberties of setting up airflows and things with the ECONET zoning. On your fully modulating equipment, I can have up to 6 zones, or 5 zones with the bypass. I cannot put more than 6 zones or 5 with a bypass in any of my communicating zoning. Now that's the fully, keep note here, that's the fully modulating equipment. With my mid-tier inverters today, which has changed, because my old 17 SEER I could have up to 5 zones or 6 zones on a 17 SEER. But on a 15 and 16 SEER today, I'm limited to 2 zones. I cannot put more than 2 zones in that. And here's the reason. Because the mid-tier product is variable speed, but it's variable speed from 45% to 75%, and it snaps into 100%, which is another training day of how that works. Okay? And just the reason I can use a contactor on the mid-tier and I have an inverter board is because now on the mid-tier product, I'm manipulating the hertz. I'm not manipulating the voltage.
nice.
So when that goes into 100%, I can't have more than 2 zones on that system because I go to full capacity. And we'll go into 100% on the mid-tier below 32 and above 90. Did they change that to above 92? It snaps to 100% on the mid-tier product. So once I hit 30 degrees or whatever, needs a call, it's probably going to snap to 100% capacity on the mid-tier heat pumps. Same on the air conditioners, just different temperatures, but most of the time it's heat pumps. And you get back to the 80s, if you're not selling a lot of heat pumps, you just will get used to it because whether we all like it or not, I preach this everywhere. The green is here. And last year, Hardy, which is a big distributor, reporting company for distribution in the country, you know, the first time last year, heat pumps tied gas furnace sales in the country. And they're going to go above gas furnace sales. So that's why they're looking to get rid of 80s. Because the heat pump sales are going through the roof. It's here. So,
I just want to emphasize one point. Guys, if you look down here to the bottom, do not zone single-stage gas furnaces and air handlers. Not to be zoned and will not be supported. That's important. Why? Because of what he talked about in the beginning. We need that stage independent on that smallest zone, right? So I want to reiterate that, even though he went through that, that's important. I know we've done it in the past with Honeywell boards and things like that, but that's why we're trying to keep you from running into future problems. We need that two-stage furnace so that we can accommodate our smallest zone, right? So just a reminder.
the only way I'd zone a city, well, first of all, we can't communicate with any of our single-stage product, but the only way I'd zone single-stage is if I got monster zones and I can dump air because of the all of today's zoning is about the indoor motors and CFM now. We have to get that ingrained. It's not about size of equipment as much as it is about CFM, static pressure, and what these motors can handle in the smallest zone. Okay? That's why they don't want any single stage equipment, because everything in our single stage furnaces is constant torque motors. And we've taken a constant torque motor, in case you don't know it, into our mid-tier lines, and it's communicating unlike the old constant torques now. We still have 1 through 5 taps on the constant torques, but the number 1 terminal is a pulse width modulating communication terminal talking to the board. It's talking to our mid-tier outside units, and it's varying the speed with our mid-tier product. So if my outdoor mid-tier 15 and 16 series running at 45%, guess what's happening to my indoor constant torque motor? I'm not picking a speed anymore. It's pulse width communicating back and forth to my board, telling it I need 45% of whatever tonnage I got sitting out here for blower. That's how I'm moving my blower speeds up and down with constant torque, not a true ECM. So we kind of have 2 true ECMs, but we kind of don't, because they're still constant torques. But now they put a pulse width modulating communicating terminal on 1 that's talking to the boards. And the other thing to remember about the mid-tier product is I need 4 wires to that mid-tier product outside from the furnace, even if I'm using a traditional thermostat, because my outdoor units communicate with my furnace, controlling the blower speeds in my furnace. So my 15 and 16 series, this is a little outside of zoning, but we haven't really done a mid-tier training. Just so you know, I can sell a regular thermostat on a 15 or 16 series product, heat pump or AC. But I have to have 4 wires outside. I have to communicate with the furnace it's hooked up to, or the air handler, because it's got to move the blower speeds up and down from 45% to 75%, and then get it up to 100%. The other thing too to know that I should bring up is what is the CFM per ton we're using today in our high efficient equipment? Anybody know?
350?
Yeah, it ain't 400. In some cases, I can get away with 325. So I got wiggle room with some airflow too, because I don't need 400 CFM specifically for this stuff to operate right. I've got a range from 3 1/4 to, I got some systems out there running on 300, and they're working because of the efficiency and because of this capacity of evaporative flow. So we got to keep that in mind too.
So let's bring it back. I can see the wheels turning. I can see questions being asked without being asked. We did a heat load. We're going into this house. It's always had a 3-ton, it's always had a 4-ton. Heat load requires that. The windows, about the ceilings, whatever. So we've done our heat load calcs, but we're going into that's great on new construction because we can design our ductwork for that heat load, right? But a lot of you guys are going into retrofit. All right, you're putting our ECONET zone on old ductwork. Well, it needs 3 tons of cooling. Fine, we understand it needs 3 tons of cooling. Your ductwork cannot handle it. So no longer can we go in with the famous 3 fingers. That house is 1, 2, 3 tons, right? Now we have to, because of these motors, what Dave's getting to, we have to look at our ductwork first and foremost. Can my ductwork handle the new 3-ton? Do I have enough airflow to handle that new 3-ton? So it almost throws heat loads out the door, doesn't it? Because either that or we got to fix our ductwork. It's a conversation we got to have with our homeowner, right? You had this before, but with the new technology and the new equipment, here's what I have to do for you to be able to be comfortable, to be efficient. You know, you need this much heating and cooling. In order for me to achieve that for you, we have to talk about changing some ductwork because our motors no longer will allow us to do that. There's no wiggle room anymore, right? We're trying to explain where you could get a little bit, but at the end of the day, we have to walk in and look at our ductwork when we're sizing our jobs or when we're doing our changeouts. You know what I mean?
By the way, if I put a 20 kW in a 4-ton air handler, I have no choice for airflow. You're gonna need at least about 1600 CFM for if all 20 kW that electric heat kicks in that you gotta move. And if you don't, you're gonna have limit trips, you're gonna have all kinds of issues with that electric heat work. I cannot adjust that electric heat CFM. Now, all our heater kits now are communicating with the board. They're communicating and coming on in stages rather than all at once, or just getting an option for a W1 and a W2 like we've had in the past on generic air handlers, you know, the regular Ruud single-stage air handlers. All our heater kits are communicating with the board. So it's going to stage electric heat on through the communicating stat instead of bringing everything on at once. But keep in mind, and again, this is one I run into yesterday, so it's fresh. If I don't have 4 tons of airflow for the pump, I sure as hell don't have 1600 CFM for the electric heat if all 3 stages kick in either. So I can adjust the electric heat I put in the air handler too. I may want to think about an 18 kW or a 15 kW. Because again, if anybody sitting here has ever really done a heat load, you'll crack down both legs when you see the heat load, actual heat load of what you think needs to be in this house. That's why everything's oversized. Or it's oversized because guys used to keep floor plans and they didn't have a 70, they put 100 in, they upgraded it. And I get the argument, well, the customer don't want to downsize. Well then guys, I don't care what the customer wants. The customer don't know their duct system. It's your headache once you put it in. So if you aren't sizing it right and the customer says, no, I want 115 furnace, and you just throw it in because that's what the customer wanted, and it's too big, we can't fix that. We can lock it down a stage if it's a 2-stage, or if it's especially in this zoning. There's a little wiggle room, but there's not a bunch of wiggle room to fix that short. Okay, well, you've oversized the furnace for the ductwork you got, customer got what they wanted, and now you got a headache. Argument I just had with a guy the other day over St. Louis. Well, it's hard to sell a customer a downsize. Well, if the ductwork's not there, it's not there. You want the headache. Or you want the headache, fine, because you're gonna have a headache with the new equipment. Okay. HMV with an 18-SEER pump, how many zones can we put in? Anybody want to guess?
That one was up to 6, wasn't it?
Yeah. Up to 6. How about an RH3V with a 15 AZ condenser, mid-tier?
That was only 2, I believe.
How about a 98V with an 18-SEER condenser?
It's up to 6 as well.
Okay, how about a 97MV with a 16 AC?
That's a trick question, isn't it?
No.
Then it would be
The 16-SEER, which is mid-tier.
It would be 2 because of the 16, right?
Yeah. Remember, 15 and 16-SEER are mid-tier. Our upper tier is the 18. We only have one upper tier outdoor unit currently, and that's the 18-SEER. Previously, it was the 20s and the 17s, but with all the re-ratings, it's the 18s and 16s and 15s. Anybody know why we re-rated? Anybody know what the manufacturers were allowed to rate these and put these AHRI values on for static pressure in the past?
It was really weird, I know that. I remember a guy talking about it.
1.5 inches is what they were allowed to test this stuff to get ratings at. There ain't a system out there at 1.5 inches of static. The re-regulation says it's got to be at least 0.58 when you test. So now they're testing